In this video, we are going to look at slant asymptotes and how to find a slant asymptote of a rational function. First, you want to look at a function just to even see if there exists a slant asymptote. And what you do is you look at the leading terms of the numerator and the denominator. So the little example that I've given right here, if you notice, you have x cubed over x squared. So a slant asymptote exists when the function has degrees that is one more on the top than in the bottom. So in this case it works because it's 3 over 2. It would not work if we had x to the 5th over x squared. It has to differ by only 1. So when we want to find a slant asymptote, we're basically going to divide the denominator into the numerator and see what we get. The quotient when we divide is our answer. The remainder has nothing to do with the answer. So basically we'll divide, for this example 1, let's go ahead and work example 1. We'll divide x minus 5 into x squared minus 25. The quotient is my answer, and it should be in the form of y equals mx plus b, because that's the equation of a line. Okay, so let's look at example 1. We have x minus 5 needs to be divided into x squared minus 25. I'm going to use long division. Now if you notice, x squared minus 25 is missing the x to the first power term. So when we write this out, we always want to make sure we have something to fill that spot. So we have x squared, I'm going to say plus 0x. And I'm ready to do long division. The good thing is it should be a short long division problem, since my answer is only going to be x to the first power plus or minus a number. Okay, so with long division, let's see, we're going to do x minus 5. We're going to look at x, and then we're going to see how much it goes into x squared. So basically, I tell myself, what do I need to multiply to get x squared? And that would be by x. So remember, once you do that, you have to distribute things through. So I'm going to do x times x is x squared. And then x times negative 5 is negative 5x. Now remember, we have to subtract to get our remainder, and the way I always think about it, when you're subtracting, you have to subtract each term. So you can just change the sign of each one, and then you can add. So I have x squared minus x squared is 0, and 0 plus 5x is 5x. Now we just have to divide x minus 5 one more time. Let's bring down our negative 25. Okay, so now once again we have x minus 5 is dividing in. We have to tell ourselves how many times will I have to multiply x by to get 5x. That clearly is 5. So we have x plus 5. Don't forget, you have to distribute through. So 5 times x is 5x, which is what we want. We want them to match up. And then 5 times negative 5 is negative 25. We need to subtract. So remember, you can change both signs and add. When you subtract those or add those, you get 0. Okay, so we're finished. Your answer in this case is always the quotient, and notice that was x plus 5. So my slant asymptote in this case is y equals x plus 5. The remainder happened to be 0, but the remainder has nothing to do with it. If we had even gotten an actual remainder, that wouldn't have affected the problem at all. So let's look at example 2. Looking at this function, we have 8x cubed over x squared. So remember, the degrees is one more than in the top than the bottom. So we have x cubed over x squared. There exists a slant asymptote. So let's find it. I'm going to use long division again. Now notice in the bottom we have x squared plus 2. We are missing the x term, so I'm going to put a 0 in that place. And I'm dividing into, let's see, 8x cubed minus 9x squared. We're missing the x term in that one also, so I'm going to put a 0 in that place, plus 1. All right, so for our long division, we look, the first two terms, we have x squared and we have 8x cubed. You basically tell yourself, what do I need to multiply x squared by to get 8x cubed? Well, we know we need an 8, and we need one more x. Right? So remember, we're going to distribute it through to each term. So we have 8x times x squared gives us 8x cubed, which is what we want. They match up. 8x times 0 is 0x squared. And then we have 8x times 2 is plus 16x. So we need to subtract. Remember, you subtract each term, which is the same thing as change the sign of each term, and then add. So we have 8x cubed minus 8x cubed is 0. Negative 9x squared plus or minus 0, it really doesn't matter, gives you negative 9x squared. And then you have 0 minus 16, it's minus 16x. Let's see. All right, so let's pull the 1 down, and we just have to go through the process one more time. Okay, now let's look and see. We have x squared is going into negative 9x squared. All right, so we have, let's see, negative 9 is what we need to multiply by. All right, that will give us negative 9x squared. So remember, negative 9 we have to distribute through. So negative 9 times x squared is negative 9x squared. Negative 9 times 0 is 0x. And negative 9 times 2 is negative 18. Okay, we're going to subtract and get the remainder, but actually you really don't have to, because remember, the quotient is our answer. We already have the quotient right there. Let's go ahead and finish the problem though. If we subtract, remember the quick way to do it is to change every sign. So change it and add. So we get 0, negative 16x plus 19. So that's our remainder. Once again, the remainder has nothing to do with the problem. So my slant asymptote is y equals 8x minus 9. The slant asymptote is the quotient. All right, and one last problem. Number 3 over here, we're kind of running out of space, but it really doesn't matter. If we look at this, you notice you have x to the 4th over x to the 1st. So you have x to the 4th over x to the 1st. Remember, your degrees tell you everything. So a slant asymptote exists if the degree in the numerator is 1 more than the denominator. Since this is 4 over 1, there is no slant asymptote. So we would say no slant asymptote.